4, 3, 2, 1. We have liftoff.
Have liftoff.
Good morning. You are looking at a live view of the Falcon 9 rocket with the Dragon spacecraft sitting on the SpaceX launch pad at Cape Canaveral Air Force Station in Florida. Hello, and thank you for joining us today. My name is Jessica Jensen. I am the manager of the Dynamic Environments Group here at SpaceX, and we are webcasting to you live from SpaceX's headquarters in Hawthorne, California, just a few miles east of the Los Angeles International Airport. And our launch desk is sitting out on the manufacturing floor, which is very cool for two reasons. One, if you look behind me, you can see the next Dragon actually being built up for launch in our clean room. And the crowd is actually starting to build here for launch. So it's getting exciting. We hope it's all gonna go off today. So this is the third test flight for the Falcon 9 rocket and the second test flight for our fully operational Dragon spacecraft. And this is an unmanned mission. We are carrying cargo to the International Space Station for NASA, where we hope to become the first private organization to ever send a spacecraft to visit the International Space Station. This is something that literally only a few nations have ever achieved, and it's going to be an incredibly challenging mission, but we've tested everything and we're ready for it. And speaking of testing things, this is actually our second launch attempt. Our first one was 3 days ago on May 19th, where we actually got all the way up to the liftoff sequence and aborted due to a high chamber pressure on engine 5. But we're going to talk about that in a few minutes. First, I actually want to introduce my co-hosts from the SpaceX team. And we have first John Innsbrucker. He is the product director for the Falcon 9 launch vehicle. John, can you tell us about that?
Sure. Good morning. As a Falcon 9 product director, I help plan and integrate the development, production, and test of the Falcon 9 launch vehicle. I've been at SpaceX since October 2006, a little more than 5.5 years. Prior to that, I served in the U.S. Air Force. There's a shot of me standing in front of the Titan IV rocket. I was manager of Titan II and Titan IV rockets. After that, I was director of the Evolved Expendable Launch Vehicle program. I've got about 28 years in the Air Force of launch acquisition, operations, and launches behind me. And interesting to note that my very first launch, February of 1980, was from the same launch pad we're going to be flying Falcon 9s out of at Vandenberg in the near future. And I'll tell you, it's been over 30 years, but this is still the exciting thing that you get to do, and looking forward to bringing it to everybody in just a little bit more than 40-some minutes.
Very true. Also with us, we have Kevin Brogan. He is a senior staff engineer in the propulsion group, and as of, I believe, 2 minutes ago, it is actually his birthday today. So we're hoping that Falcon 9 puts on a good show for his birthday. But why don't you tell us a little bit about what you do here, and you've been here for a while, so.
Sure thing. Yeah, I'm a longtime SpaceXer. I've been here since 2003. I've worked on all sorts of propulsion projects, just about everything that we've developed here. There is a really vintage pic of me back in about 2005 with the upper stage engine of our earlier Falcon 1 vehicle. I've also worked on a couple things we're going to see in action today, and that's going to include Draco thrusters, which are going to maneuver the Dragon capsule when it's on orbit today. And I also did some of the mechanical design for the primary heat shield that Dragon uses, which if all goes well in about 10 days or so, it should use when it tries to re-enter Earth's atmosphere. So I'm excited about that. And I'll certainly take a birthday present of getting into orbit today if it all works out. And so maybe tell us a little bit about what you do, Jessica.
Sure. So I joined the company back in June of 2006, just after our first Falcon 1 launch. And there's actually a picture of me standing next to the second flight of the Falcon 1 rocket. I was working out in the Marshall Islands, helping do instrumentation for it. So what my group does is we're actually responsible for ensuring that every piece of hardware on Falcon 9, the rocket, everything, and that the satellites, cargo, and eventually crew we help to fly can all withstand the vibrations that the engines induce. And we actually we're working to make the quietest ride possible. So that's what I do.
We appreciate that. And of course, we're just three of over 1,800 people here at SpaceX that design, build, test, and fly this Falcon 9 vehicle and the Dragon spacecraft. And we're very happy to be part of NASA's public-private partnership and really help lower the cost of access to space. And hopefully we're going to see some good action here pretty soon.
Yep. So today's webcast is going to last about an hour if all goes as planned. And what we're going to do is we're actually going to recap a lot of the stuff we mentioned in the webcast on May 19th. Just because I know we have some new viewers, we want to make sure we cover everything. But we'll try and throw in a couple tidbits of stuff so that those of you who watched on May 19th can get a few little extra pieces of information. So what we'll go over first is we'll talk about what you can expect to see during liftoff and ascent. Then we'll describe the plan for the roughly, it's now a little bit condensed, 2-week mission on orbit. And then, yes, once we do that, actually, we're going to jump over and let's talk about the launch abort that occurred on Saturday. And John's going to start us off for that.
Yeah. For many of the folks who saw or have read about it, we did abort the countdown just after we ignited the 9 engines on the Falcon 9 first stage. The flight computer detected that the normal expected pressure was a little higher on the center engine, or what we call engine 5. After we finished the abort, we got the crews back out to the launch pad where they found a failed check valve. Check valve's about this large in size. Found that on the Falcon 9. We were able to work on the Falcon 9 while still vertical. We didn't have to bring it horizontal or bring it back to the hangar. What the crews found was the check valve had failed open. This allowed liquid oxygen to flow from the main injector over to the gas generator injector. That results in the higher than nominally expected pressure in the main combustion chamber. We were able to we removed and replaced the check valve with another unit. We have checked it out, done leak checks, make sure the valve functions. Everything with the check valve looks good. We also spent a lot of time Sunday after replacing the check valve Saturday night. On Sunday we did a data review both on Dragon and Falcon 9, looking at the results from the countdown, seeing if there was anything else to be gleaned from the data. Everything looks good. So we've replaced the one piece of discrepant hardware. We had a chance to look at everything. The vehicle's ready to go. The crews got a little more exercise, and we're coming up at T-minus 37 minutes, and we're going to be good to go.
Yeah, it's worth noting that the system really worked exactly as designed. You know, we built into our launch system the capability and, in fact, the requirement that before we launch, we take all the engines up to full power, and while we're doing this, our engine computer checks all of them out and looks for anything out of family. In this case, in fact, it did find something out of family. It aborted the launch, and it put the vehicle in a safe mode, which is exactly what we wanted to have happen. In that time, our engineers were able to dig into the data, look at the hardware, and see exactly what happened. We did find a mechanical failure, but our launch system is specifically designed to find this before we take off. So I couldn't be happier that things worked out the way they did. That's exactly how we design our system, and you know, we really hope that we go off at T0 today, and if we don't, I'm sure there'll be a good reason for it.
Yeah. So yeah, SpaceX engineers worked all weekend to go over this, and we are ready. There should be one thing I want to note, that even though now we're 3 days later, we still have an instantaneous launch window. That is the one thing that actually has not changed.
Right.
So,
yeah, we have basically right now we're scheduled to lift off very precisely at 7:44 and 38 seconds universal time code, which is about 3:44 in the morning on the Pacific side and 12:44 in the morning here, or 3:44 Eastern, 12:44 Pacific. Which is common. Any vehicle traveling to the International Space Station is going to have a very short launch window. It can be up to 6 to 8 or 10 minutes. For us, we're choosing to launch at our very exact nominal time. If we launched off of that time, what that would mean is our Dragon vehicle would have to use extra propellant to reach the station. In this case, we want to do a lot of test maneuvers with the Dragon vehicle, so we want to save about as much propellant as we can, so we're choosing to go with an instantaneous launch window. Any delays or holds, we'll scrub for the day and probably go again on the 25th, but we'll look at that down the road. Right now, I think we're looking decent to go.
great. All right, so as Kevin mentioned, you know, you can stay, basically if anything happens, whether we scrub today or hopefully we will go, no matter what, you can check your updates at SpaceX.com. We will be posting updates there and hosting webcasts for more key events. You can also check out our Facebook and Twitter pages. And lastly, you can look on YouTube, where we've posted previous videos of launches and test firings in Texas that are really cool. Oh, one more thing. Elon is tweeting from the mission control conference room. So if you actually go to the Twitter page and look up SpaceX, you can read some of his tweets there, which is pretty exciting because you're hearing it right from him. He's sitting right in the control room, and it's pretty cool.
That's great.
So, all right, well, let's go back and take a look at Falcon 9 on the launch pad and get our first launch update from John.
Sure. We're at T-minus 34 minutes and 15 seconds. Let's take a look at the status of the various pieces that are going to make up today's launch. Out in Florida, we've got Falcon 9, which is being operated out of the Launch Control Center, where about 24 folks are taking Falcon 9 through its last paces currently. Right now, we began loading propellant on Falcon 9 about 3 hours ago, finished up about an hour and 50 minutes ago. So fuel's on the first stage, on the second stage, liquid oxygen's on both stages, and we're topping it off. You can see the gaseous oxygen plume coming off of the vehicle as we keep making up a little bit of liquid oxygen in the tanks as it boils off as we wait for T0. We completed flight termination safety checks with the range a couple of hours ago. We've lowered the strong back for launch, and we're pretty much waiting for the next major activity, which will be going into the terminal countdown sequence at T-minus 10 minutes. In addition to Falcon 9, we've got Dragon on this mission. We'll be flying the Dragon spacecraft to low Earth orbit, and we're operating that out of the Mission Control Center here in Hawthorne, just off of our set. There's a shot of Mission Control Center right now. They are taking care of Dragon. They have finished its final configuration for launch. Dragon's fairly quiet right now. Its next major activity is going to be switching to internal power at about T-minus 8 minutes, and we should hear that on the countdown net when we get into the terminal count sequence. Mission Control Center is also in communication with Johnson Space Center, where they're operating the International Space Station. They're exchanging the schedule data, the status data, making sure both sides are ready to go. The latest report we've got is that NASA is also go to support the launch this morning. That takes us up to the last major piece, and that's the range. Range status is green for launch. Those are the folks at Cape Canaveral and the Air Force side that are providing the infrastructure and the services we need to support the launch. The safety hazard areas have been cleared, the roadblocks are put up. They're also providing the flight termination systems. They're doing the cameras and the radars. And right now, everything that they've got that supports the launch is green. The next thing that we'll also be doing is watching balloon data. The balloons right now and the overall weather is green and good for launch. Balloons show us that we are capable of flying through the upper altitude winds. And the weather data shows us, at worst case, about a 10% probability of violating constraints, which this time of the year in Florida is about as good as it gets. So right now the winds are calm, things look good, weather's good, rocket's good, control centers, Dragon are good, and we are now 31.5 minutes away and everything is green and quiet. And let's hope it stays that way.
I love it. This is exciting. So last week we solicited questions from our Facebook and Twitter followers, and during our last webcast we actually answered some of those. What we're going to do is recap some of the questions and cover some of the answers since some people missed that. So a lot of questions, I actually get asked this by my friends a lot, is how are you affiliated with NASA? Some people think we're actually competitors or we're not affiliated at all. And the truth is NASA is actually our customer on this mission, and we've been collaborating with them for several years now. So this mission is part of a larger program that was initiated by NASA to develop commercial space systems. And what that means is generally it's going to save the government money, which is good. And this specific program was designed or developed to see if space providers could develop or transport cargo to and from the International Space Station safely, reliably, and cost effectively. And doing this in a commercial way for these specific missions, what that does is allow the government to save money so that NASA can then maybe spend its money on, say, other exploration efforts, which is great. So to sum up, basically, NASA is our customer, our partner, our mentor. They've helped us along the way. We would not have come nearly as far as we've come today if it wasn't for their help. And you know, we're excited, we thank them, and we're super excited to keep working with them on future missions. So no, NASA is not our competitor for whoever possibly thinks that. All right, so we're gonna go back over to John now, where he's gonna talk about the launch phase and more of the Falcon 9 rocket.
Sure. Just like our last flight in December 2010, Falcon 9 is launching from Cape Canaveral, Space Launch Complex 40, to put Dragon into a low Earth orbit. Falcon 9 is powered by 9 Merlin engines on the first stage. There's a shot of typical engine section of the Falcon 9. I mentioned earlier we had to replace a check valve on the center engine, or what we call engine number 5. Here you can see the center engine is literally the one in the middle of the tic-tac-toe pattern. We build these engines here in Hawthorne, California. We take them to Texas, where we test the engines. We then install them on either a first stage or a second stage. We then test the stage, and then we transport it, in this case, to Cape Canaveral, where we do final assembly and prepare to launch. Now, once we ignite the engines, it takes about a second to get up to full power. Now, the computers on the rocket will check out the engines. As you saw or heard on our first attempt, we can stop the launch if we detect something that is out of the ordinary. Once we pass these final checks right before that critical T0, the rocket computer then commands the launch mount to release the vehicle for flight. Now, once we're in flight, the engines will put out about 1 million pounds of thrust. Here's a shot that's looking back towards the launch pad from a camera that we put on the second stage of the Falcon 9. The vehicle's about 157 feet long, or about 48 meters. And you can see the launch pad, in this case, receding into the background, although tonight, with the darkness, we may not see much of the pad once we clear the towers. You can also see a circular opening just along the side of the rocket. That's where the second stage umbilicals that carry fuel, liquid oxygen, gas, electrical, plug into the second stage. They get ejected at liftoff. We climb out through the atmosphere and we go supersonic, faster than the speed of sound, at about 70 seconds. On the first Falcon 9 launch, that was indicated by this great shot of a shock wave forming around the front of the Falcon 9. But for tonight, again, in the darkness, I don't think we're going to be able to see that. We'll fire the first stage engines for about 3 minutes, at which time then we shut them off. We'll coast for a moment before we get to stage separation, and that's one of the most critical moments of the launch. At this time, we're 90 kilometers up, about 56 statute miles, and we're going over 10 times the speed of sound. We activate our stage separation system. SpaceX, we use a non-explosive system, something that we can check out and make sure is working. Instead, we use a high-pressure helium gas, which will push the first stage away from the second stage. That exposes the upper stage engine nozzle that you can see, that gray nozzle in the picture. The second stage engine will then ignite and continue pushing Dragon on the rest of the way into the low Earth orbit. Now, at this altitude, the exhaust plume of the engine is nearly invisible. Instead, what we should see tonight is the large expansion nozzle glowing red hot in the darkness of space. Red hot glow is normal for that upper stage engine. You may also see a smaller nozzle. In this picture, that's that little silver nozzle superimposed on the red hot nozzle. That's our roll control nozzle. That'll move back and forth every now and then. That helps give us the needed guidance to keep the stage lined up and going into the proper orbit. We'll fire the upper stage engine for 6 minutes, and that gets us up to the magic velocity of orbital speed, 17,500 miles per hour, or about 7,800 meters per second. Once we get into orbit, the second stage engine is commanded to shut down by the flight computer. And that brings us up to the big event when Dragon spacecraft is commanded to separate from the second stage and it heads out on its own. From start to finish, Jessica, it's going to be an exciting 10 minutes, and we are right now just 25 minutes and 45 seconds away from being there.
All right, keep getting closer. So today's launch is going to take us northeast over the Atlantic Ocean. We're going to pass over the viewable ranges of ground stations in Wallops, Virginia and Newfoundland, Canada. Good news for that is you'll actually be receiving live video with no delay from liftoff all the way till we get on orbit. Then sometime close to Dragon separation and deployment of the large solar array panels, we're going to be losing coverage around there, but hopefully we'll get to see those events because that'll be really cool. Now at the point we actually lose video coverage, we're going to bring you back to Hawthorne and wrap up today's webcast. Now when we do that, we've lost the video, but the reason we lose video is because that's a very high data rate channel and we can only get that over certain ground stations. So the mission control engineers here will still be communicating with Dragon throughout the entire mission. We won't lose any of that. And we will be taking those, whatever we find out from them, we'll be posting updates on SpaceX.com and through our Facebook and Twitter pages so that everyone can stay up to date with Dragon's progress towards the International Space Station. And that's actually now what Kevin and I are going to talk about, how are we actually going to get there once we're in orbit.
Right, just a reminder, what you're going to see today is only the ascent phase. We got a lot of work to do. It's going to be 3.5 days before we get to the station. So once Dragon reaches orbit, SpaceX Mission Control here is going to communicate with it and perform a whole series of checkouts. This is going to include everything, including batteries, power systems, the communication and navigation, the Draco maneuvering thrusters, and much, much more. This happens for about the first 2 orbits or so. After that, we settle in for about a full day of catching up with the International Space Station. And at that point, we're going to be in the vicinity of the station and start a whole series of tests. Real quickly, I would recommend everyone download our press kit on the website at spacex.com. This has a really detailed mission timeline, talks about everything we hope to accomplish, also gives some great history about SpaceX, about our collaboration with NASA, what our cargo is, some of the other commercial suppliers that are in the same program, and even the 45th Space Wing. So there's a lot of good stuff here. Download this at spacex.com. We're going to give you just a brief overview right now of what Dragon's going to do on orbit. So once we start catching up with the International Space Station, we're going to basically get in the vicinity, which means about 10 kilometers away. At that point, we start a very detailed series of missions where we perform a fly around. At this point, it's really a very complicated orbital dance. You're seeing a very simplified picture now, but it's a very complicated orbital dance where we get as close to 2.5 kilometers and about as far away as 10 kilometers. During this time, Dragon's going to be communicating with the space station, and in fact, the crew aboard the space station has a control panel for Dragon, which they're going to use to turn on a strobe beacon and push the Dragon away, which is part of a tested abort scenario. After we perform a whole series of maneuvers, our team here in Mission Control, as well as NASA and the international community that run the International Space Station, are going to review all the data and confirm that they think Dragon at this point is safe to go to the station. If everyone gives us a green light, NASA is going to give us the final go-ahead to approach the station. It's going to be a really exciting time, and when we do this, Dragon is going to start approaching the station from the direction of the Earth. It's going to move really slowly, and it's going to slowly nestle itself up till about 10 meters or 30 feet away from the station. At that point, it's going to go into a holding position, and astronauts aboard the station are going to use the Canadian robotic arm, and they're going to reach out and they're going to grapple the Dragon vehicle, and they will maneuver it into place to berth it with the Harmony module on the space station. This operation takes over 5 hours, so it's a very slow mission, but it's very precise. The astronauts aboard the station that are going to be doing that are the US astronaut Don Pettit and European astronaut Andrei Kuipers. Here's a great picture of them when they were in Hawthorne doing some trading with the Dragon vehicle. And right now they're on board the space station awaiting the Dragon vehicle. These guys are some real rock stars of the astronaut community. And in fact, Andrei Kuipers took this photo just 3 days ago of our launch facility when they were flying over it. Of course, we had hoped to launch at that time, but we didn't. So once we've docked with the station, the Dragon vehicle is going to connect itself to the power of the space station, and at that point we're going to cease operations for the day, and the next day is going to be
Hatch opening day!
Yay!
So the astronauts are obviously on the space station side, so they open the space station side of the hatch. At that point they have access to Dragon. They open the Dragon side of the hatch and they can begin to climb in and unload cargo. So as you can see on this photo, that is the SpaceX facility, and a whole bunch of NASA cargo is getting ready to get loaded onto Dragon. And of course, everyone is curious as to what we're actually bringing up to the space station. And we have all kinds of stuff. We have, let's see, over 300 kilograms, which is about 700 pounds of food. And yes, it was asked if we are bringing fresh fruit, but unfortunately, a lot of this cargo was actually loaded a couple weeks ago, so no fresh fruit this time, but hopefully get some soon. Some other stuff we're bringing are computer supplies and laptop batteries. Also, there's a bunch of really cool student experiments, and these student experiments come from, I think, middle schools and high schools all over the country, which is really cool. And they have science goals ranging from, the rate of bacteria growth in microgravity to how to purify water in space. So I know all these kids are super excited to see their experiments actually launch into space, and hopefully they'll get some really cool data back. It'd be great for them. All right, so then towards the end of the mission, now we've taken all this cargo off and put it onto the space station. The astronauts are now going to load up about 600 kilograms or 1,300 pounds of cargo for the return mission. And this is great too. We want to be able to, transfer things to and from Earth. So What we're going to be bringing back is some science experiment hardware, some metal alloy samples from microgravity processing experiments, and the coolest thing is spacewalk gloves from some of the previous astronauts. We'll be able to bring that back home, which is fantastic.
Yeah, that's some great stuff, and it's good to be able to bring it back.
It's true.
You know, it's worth noting that with the retirement of the space shuttle, the Dragon capsule is the only way to bring back significant amounts of cargo from the space station. Of course, the Russian Soyuz vehicle can bring back 3 people, but only a very, very small amount of cargo. I think each person gets about a lunchbox size of cargo. There are other vehicles that visit the space station. They include the Russian Progress, the Japanese HTV, and the European ATV. But none of those vehicles have re-entry capability. In fact, they're usually filled up with trash and jettisoned to burn up in the atmosphere. Also, another commercial partner, Orbital Sciences, is building a commercial vehicle to visit the space station, but it also does not have re-entry capability. So we're very excited to be able to bring back a lot of great stuff from the space station, and we're really hoping to see that happen in just about 10 days or so.
Yes. So at that point, it'll be our last day on the station. It's going to be around May 31st. And at that point, the astronauts will close up the Dragon side and then close up the space station side, and they will actually unberth Dragon using the same Canadian robotic arm that actually brought us towards the station. Then, what actually happens next is the trunk separates from the capsule, and the capsule itself is actually going to be the only thing that is returned to Earth. And what happens is Dragon fires its Draco thrusters, and that's what starts it on the actual re-entry process. As Dragon comes into the Earth's atmosphere, it is protected by the SpaceX-made high-performance Pika-X heat shield. And what that does is actually protect the vehicle while it's slowing down from the 17,500 miles per hour on orbit speed. And it's got to slow down to less than Mach 1, which is about 750 miles per hour, at which point the parachutes will deploy. And Dragon will begin its nice, slow descent into the Pacific Ocean, where it's going to splash down about 500 miles off the coast of California.
That's going to be awesome, and we're going to have a crew there to pick it up.
Yep. Here's
Here's a really great photo of our team back in December of 2010 when we orbited a capsule and recovered it. A great group of guys there. You know, as hard as it is to get something into space, it's almost harder to get it back. So we're really happy to validate that capability, and we look forward to bringing some stuff back from the station on this very mission.
Great, thanks Kevin. So that sums up most of the stuff we were going to cover during this webcast, and it looks like we have a little bit of time before we go into the conductor's poll. So we're going to go over a couple of the questions that were asked last week from our Facebook and Twitter fans. And one of them was, or a couple, actually a lot of people asked this, they're wondering, is our rocket reusable, and will we be recovering the first stage on this mission? John, can you answer that for us?
Sure, I can. On previous missions of Falcon 1 and Falcon 9, we have tried to recover the first stage, but it's proven to be pretty difficult. If you've been following SpaceX, you know that one of our long-term goals is the capability to rapidly reuse the vehicle and fly it again. So we're working on that. We're doing design work, test work right now, but again, that's a goal that we're still pursuing. For today's flight, we don't have any parachutes in the first stage. We didn't pack the mortar that fires the parachutes out. So once the first stage gets pushed away from the second stage, it'll re-enter the atmosphere on its own, break apart, and we won't be trying to recover it today.
Very true. So another thing that people ask about is, so the statistics have shown basically that there's a high probability of an issue occurring on one of the first 3 flights of a new launch vehicle program. And since we are a new launch vehicle program, people are wondering, are we worried about this? Kevin, are we worried?
Well, of course we're worried. You know, we're engineers. You know, being worried is what we do. We try to predict absolutely everything that could go wrong with this vehicle and then design it to handle that capability. In fact, the launch abort we had just last week is a good example of something that worked right. You know, we designed in the capability for us to check out our engines before we released the vehicle, and they were able to discover a mechanical problem, which we were able to fix. So we've done a huge amount of testing. You know, we test this rocket more than anyone does, and we're really excited about it. Of course, the Falcon 9 vehicle is really only half of it. You know, we design, build, and test the Dragon as well here in this facility. And we've designed all kinds of multi-redundant capability into it, and have had some great help from NASA and their mentoring. So this is a test launch. You know, we want to stress that this is a test launch of the launcher and the Dragon capsule, but of course if we didn't think it was going to work, we wouldn't test, or we wouldn't launch. So we're really excited to get a shot at it today.
Yep. So the crowd is building. It's grown a lot since we've even just started this webcast. You might be able to hear them cheering a little bit in the background. So it's getting close, and we're going to go over to John and the rocket. So we're going to check out the rocket on the pad, and John's going to give us a final launch update.
Good news is we are still green and counting down at T-minus 14 minutes and 12 seconds right now. Falcon 9 propellants are loaded, gases are loaded. Next major activity is going to be start of the terminal count sequence at T-minus 10 minutes, and we'll let you listen into that on the countdown net when we get there. Dragon is go. It's configured for flight, except for the last few steps, like going to internal power at T-minus 8 minutes. The range is go, weather is go, and the control centers are go. And we do have a report from our guidance, nav, and controls folks that the balloon data, they've processed the most recent balloon. It shows that our capability to fly through the atmosphere is green and ready to go. So we're ready to rock and roll. Coming up here in just a few seconds at T-minus 13 minutes, we're going to listen to the SpaceX launch conductor poll the team, and they'll give their final go, no go, ready to enter the terminal countdown sequence. So we'll listen into that, and then we'll come back for just a couple of minutes.
All stations verify ready for launch. All stations acknowledge. FTS.
FTS go.
Prop.
Props go.
AVI.
AVI go.
GNC.
GNC go.
Ground.
Ground is go.
VC.
VC's go.
GC.
GC's go.
DC.
DC's go.
RC.
RC's go.
OSM.
OSM go.
ROC.
Rangers ready.
CE.
CE go.
LD.
Launch director go.
MD.
Mission director go.
LD, verify go to initiate terminal count.
LC, you are go to initiate terminal count.
Copy.
As you heard, the SpaceX launch conductor did poll the team, and everybody is go for entering terminal count, heading to T0 in T-minus 12 minutes and 10 seconds. Right now they're giving final directions to the team prior to picking up the terminal count at T-minus 10 minutes.
All right, so as a reminder, this mission is our third flight of the Falcon 9 rocket and our second test flight for the Dragon spacecraft. We are carrying cargo to the International Space Station for NASA. And on this mission, we hope to be the first privately built spacecraft to visit the International Space Station. Like I mentioned, this is going to be an extremely challenging mission, but we've been lucky enough to have NASA support and guidance over the past few years, and we've tested everything possible, so we are ready.
Again, we have a near instantaneous launch window, which is going to happen in just about 11 minutes and 20 seconds. If we have any delay or holds, we'll scrub for the day. But if we do lift off, we expect to see Dragon separation in about 11 minutes after that. And we're going to hold on to video just as long as we have it. And with luck, we'll see the solar arrays deploy, which is going to happen just 2 minutes after that Dragon separation. So we're really excited. It's going to be another 3.5 days before we get to the station. But at that point, we'll be there for 10 days. We certainly want you to cheer us on and follow us. We're going to have all kinds of updates on SpaceX.com and Twitter, providing you that information as we have it.
Yep. So what we're going to do now, actually, this is the view you're actually going to be seeing as the vehicle takes off. This is about 12 stories up on the vehicle. You can see the umbilicals coming out of the rocket right now. Those will release, and that's the view you're going to get. Some of our cameras actually have little lights on them, so we might get to see a little bit more, and the plume will actually light things up. But we're actually going to switch you over to the countdown net audio that begins at T-minus 10 minutes. And this way you'll be able to hear the launch and mission control engineers working through the final procedures in the terminal count. So let's check it out, and we'll be back after launch.
3, 2, 1, mark. VC announced the sequence has started.
Dragon terminal count and terminal count launch have started.
RCO confirmed clock is counting. GCVC standby on fire X.
Standing by. Standing by.
OSM set launch enable to flight.
Switch into flight.
RCO, confirm clock is counting.
Clock is counting.
Pre-valves are coming open. Aux bleeds are open. The M9 engines are chilling in.
Pre-valves are open for flight.
T-minus 9 minutes. T-minus 8 minutes. T-minus 7 minutes.
First stage fuel bleed open. Vehicles in self-alignment.
T-minus 6 minutes.
Stage 2 TVC bleed has started.
T-minus 5 minutes.
Vehicle and pad abort systems are setting up for launch. GN2 load has ended. Stage 1 and Stage 2 internal auto sequences started.
And we're on internal on Stage 1 and Stage 2.
Vehicle release auto sequences started in preparation for launch.
T-minus 4 minutes.
Ground T-TIB system setting up for launch.
FTS on internal power.
S2 TVC complete.
Pre-valves are coming closed.
T-minus 3 minutes.
FTS is armed.
LOX load is ending nominally. Fuel trim valves are in their flight positions.
LD, verify go for launch.
Launch directors, go for launch.
Stage 2 heaters is ending nominally.
Rock, verify range go.
Range green.
Pre-valves are coming open for one last chill. Helium load is ending nominally. Engine purge ISO is opened.
First stage engines are chilled in.
Vehicle is in auto idle.
T-minus 1 minute.
Vehicle is in startup.
The flight computer's in control of the vehicle.
Stage 1 and Stage 2 tanks are pressing to their flight pressures.
T-minus 30 seconds.
All propellant tanks at pressure.
T-minus 20.
Fire X is on.
T-minus 15 seconds. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0.
Stage 1.
We have liftoff of the Falcon 9. Falcon 9 has cleared the tower.
Starting pitch kick. Starting gravity turn.
First stage engines at full power, looking good.
We have a solid telemetry link and the power systems are nominal.
First stage propellant utilization is active.
Vehicle's on a nominal trajectory. Altitude 5.3 kilometers, velocity 225 meters per second, and downrange distance of 0.6 of a kilometer. Vehicle is supersonic. Vehicle has reached maximum aerodynamic pressure.
Propulsion's performing nominally, starting stage 2 engine chill.
We have a solid RF link and power systems are nominal.
Vehicle's on a nominal trajectory, 30 kilometers altitude, 1 kilometer per second velocity, and downrange distance 20 kilometers.
Dragon power systems are nominal.
Vehicle's on a nominal trajectory, 53 kilometers altitude, 1.7 kilometers per second velocity, and downrange distance of 51 kilometers.
Approaching MECO 1. MECO 1, planned shutdown on engines 1 and 9.
First stage impact point past mid-MECO.
MECO 2.
Nominal velocity at MECO.
Stage set confirmed.
And back ignition confirmed.
The Dragon nose cone has been jettisoned.
Stage 2 propulsion systems nominal.
Vehicle remains on a nominal trajectory, 176 kilometers altitude, velocity of 3 kilometers per second, downrange distance 320 kilometers.
And power systems are nominal and we still have a solid telemetry link.
OSM, this LC, please move to net A.
Stage 2 propellant utilization is active.
Vehicle remains on a nominal trajectory, 220 kilometers altitude, 3.4 kilometers per second, and downrange distance of 470 kilometers.
Second stage propulsion performing as expected.
Second stage power system is looking good, and we have a solid telemetry link.
Vehicle remains on a nominal trajectory, 269 kilometers in altitude, velocity of 4 kilometers per second, and a downrange distance of 712 kilometers.
All stations MD, procedure 7.100 complete. We're on procedure 7.101.
MVAC and stage 2 performance is good.
Vehicle remains on a nominal trajectory, 300 kilometers in altitude, velocity of 5 kilometers per second, and downrange distance of 1,000 kilometers. IMU sensor remains healthy, and GPS lock is verified.
And we are picking up data from New Hampshire.
Vehicles and terminal guidance. Vehicles pass through the European gate.
FTS is saved.
Roughly 30 seconds to drag and set.
MVAC shutdown confirmed.
Dragon's in
Falcon 9 and
separation.
Dragon are in orbit.
Dragon is in separation state.
Prime.
Wait.
All stations continue on your procedures.
Apogee
We're on step
346 kilometers, perigee 297 kilometers. Inclination 51.66 degrees.
Cameras forward. Dragon set.
Start of payload settling deploy.
Dragon is now free flying in orbit around the Earth. We are very excited. If we maintain video coverage, we hope to see the deployment of the solar arrays. If we lose video, everything is likely still operating nominally. We just have the limit of our signal. We have about a minute before the fairings that house the solar arrays are going to jettison, and that's going to automatically trigger their deployment. Right now, the Dragon's propellant system is priming itself, and the thrusters are going to fire, and then it will. Hope we can hold signal here. Boy, well, we have just about 40 seconds to wait for this. Let's see if we can't hold our signal and watch these solar arrays deploy.
Solar array deploy attitude. Convert Draco thruster firings. Attitude looks good. Dragon is in array deploy. Props is nominal.
Dragon solar array deployment.
Newfoundland OS.
Solar array deployment.
Solar arrays have deployed.
Well, we can see the solar arrays deploying. This is a great moment. Of course, this is just the first step of a very complex mission.
Power global.
But from all accounts, we have Dragon orbiting the Earth with the solar arrays deployed. We have a couple days worth of really difficult challenges before we get to the station, but there's both solar arrays are deployed. Dragon is performing nominally, and we are looking forward to a great mission here to the International Space Station. Hopefully become the first private company to service our international community at the space station.
Power global.
Go ahead and acknowledge, MD.
Okay, power global acknowledge. LD, MD on countdown.
LD's on a phone call right now, MD.
Yeah, copy that, LC. We're going to be switching off countdown net. Thanks for a ride. Okay, all stations, this is MD on mission A. We're on 1.10.
Dragon is in co-elliptic plan, no comm.
Well, as expected, Dragon is just about at the limit of the Newfoundland ground station. We're probably going to lose video shortly, but right now, Dragon is still communicating with Mission Control here in Hawthorne, California, and everything looks great. It continues to circle the globe. You can hear the audience here. Everyone at SpaceX, we've got 1,800 plus people. We're all working really hard, and we're on our way to a great mission. We still have 3.5 days, a lot of test maneuvers before we get to the station. So stay in touch with us at SpaceX.com and Twitter, and continue to cheer us on.
So, let's see if I can talk now. It's been a great launch today. This is the third successful flight of Falcon 9, the second time we've put Dragon safely into orbit. This is so awesome. We definitely hope to continue this success over the next 2 weeks, where we are making progress to the space station, and I feel pretty good that we are going to be the first private company to ever visit the International Space Station. This is so exciting. Please be sure to stay tuned to SpaceX.com and Facebook and Twitter and all those things. There's all kinds of great tweets right now. And, yeah, just please stay up to date with what's going on.
And we want to extend a special thanks to NASA for their teamwork and support in today's mission and getting here. To all of our customers and supporters over the years. To the worldwide network of tracking stations that are going to be helping us with Dragon going to the space station and back over the coming couple of weeks. And finally to the Air Force and the folks at Cape Canaveral for the great support in getting today's launch off of the pad.
Yes! So, on behalf of the 1,800 people here at SpaceX, we thank you so much for watching this amazing mission today. It is a great day. It's almost surreal.
Yeah.
So cool. Yeah, and just please continue to watch us as Dragon makes its progress towards the space station. And thank you.